Hello everyone, in this video I will explain the convolution of a digital or discrete time signal, and I'll go through the code step by step to show how convolution works mathematically and programmatically. First, I import NumPy for numerical operations and Matplotlib for plotting discrete signals using stem plots, which are commonly used for digital signals. Next, I define two discrete time sequences x of n, which is the input signal with values 1, 2, 3, 4, and h of n, which represent the impulse response of the system with values 1, -1, and 2. After defining the signals, I implement convolution manually to show what is actually happening behind the scenes. Inside the manual convolution function, I first get the lengths of x of n and h of n, then initialize the output y of n in a length of n plus m minus 1, which is the standard length of a convolution result. I then use two nested loops. The outer loops represent the output index n, while the inner loop represents the summation index k. The condition inside the loop ensures the only valid overlapping samples are multiplied and added, which directly follows the discrete convolution formula y of n equals summation x of k h of n minus k. Once this process is complete, the function returns the manually computed convolution output. To verify the correctness of the manual implementation, I also compute the convolution using NumPy's built-in convolve function, which should produce the same result. Then I define the discrete index values of x of n, h of n, and y of n as they can be plotted correctly. In the plotting section, the first subplot shows the input signal x of n, the second subplot shows the impulse response h of n, and the third subplot shows the convolution output y of n. In the output plot, I display both the manual convolution and NumPy's convolution together. The fact that both plots overlap confirms that the manual convolution implementation is correct. Now, interpreting the output, we can see that convolution result starts small when there are only partial overlap between x of n and h of n, increases as more samples overlap, and then decreases again as the overlap reduces. This behavior demonstrates how convolution combines the input signal with the stem's impulse response to produce the output, which is the core idea of linear time invariant system and digital signal processing.